So, as I said, we describe a function as even if for every value x where it is defined, that is every value x in its domain, f of negative x essentially does nothing. That is, f of negative x is equal to f of x, where the easiest kind of function to identify as being even is one written entirely in terms of even powers of x, something like f of x equals x squared, where for even functions we always have symmetry with the y-axis because, well, replacing negative x doesn't do anything. On the other hand, we say a function is odd if we have odd powers of x, yes, but no, not yet. We say it's odd if f of negative x is equal to negative f of x for all x in its domain. So this is the same, essentially, as saying the function has symmetry with the origin. It's that same idea that we talked about in that last section, where, as I whispered a little bit, the most obvious of the odd functions are the odd powers of x polynomials. And we can think of, in that case, throwing a negative x in as being something you just pull clean out of there, where there are some really important examples of functions that are even and some really important ones that are odd, but generally, even for things like polynomials, it's kind of rare to get just one or just the other. More often, you get things that aren't quite perfectly fitting into either definition. But anyway, we'll get one more example here, looking at trying to classify something as even or odd. So we're going to check if the function h of x equals x squared minus x to the fourth is even, odd, or neither. Where to see if the function is even, all we have to do there is take h of x and see that when we plug in negative x, we end up getting negative x squared. Oh, excuse me, I should pull that squared to the outside, being a little presumptive, minus negative x to the fourth, although you may have noticed these are both even powers of x, so you probably can guess where this is going to go, but even if you didn't see that immediately, negative negative becomes a positive x squared, negative 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 is still a positive x to the fourth with that extra negative on the front. Point is, we end up back where we started like we were supposed to. That is, we have h of x, so the function is going to be even. Now, I'll say here that technically speaking, the only function that is both even and odd is the very laziest constant function, h of x or f of x, whatever you want to call it, equals 0. But we don't do very much with that function because it doesn't do a whole lot on its own. And to be sure, you can't have in that way any more involved function that is both even and odd, but just to check to be sure that happens in this case, well, we can see that negative h of x is equal to x to the fourth minus x squared, where this is certainly not equal to h of negative x, so we have that h of x is not odd, as we may well have expected. Or the next thing we're going to see here, the next thing we're going to talk about, is a different general kind of function. It's sort of an oddball function, a construction called a piecewise function, where instead of getting some nice consistent behavior like we might see with these, we get something that's defined in stages, or, as the name might imply, pieces.